So this is the screencast for conceptual objective number 3. It's found on page 79 and it's problems 39 and 44. This one is 39. I started off by writing what we have and what we need, and I identified the physical property that we are using. It's one-dimensional motion. So I first began by writing the displacement, the first one 120 meters north and then 72 meters west. And then I drew the resultant right there, and I wanted to find the resultant, so I just did 72 squared plus 120 squared equals the square root of the resultant. So I found that, square rooted it, and I found that change in R is 139.94 meters. So now I identified the equation that we're going to use for velocity average. It's the change in R over change in T. I realized that we are given minutes when we're really going to need seconds, so I just used dimensional analysis to figure out the seconds, which was 62 times 60 divided by 1. So I got 3,720 seconds. And so now I just plugged it into the problem, 139.94 meters divided by 3,720 seconds, and that would get the velocity average, which is right there. And then the next thing that we want to get is the direction. So what I'm going to do is, this is the angle that I want to use, and then I'm going to write it like theta equals arctan 72 over 120. So if I plug that in, theta equals 30.96 degrees northwest. And that is number 39. Now 44. Okay, so I started off by writing what we have and what we need. So we need to show that the average acceleration is the same as g sine theta, when g equals 9.81 meters per second. So I'm going to start by writing our plane here. There's theta, and then this is change in x equals 15 meters. Okay. So I'm first going to identify that average acceleration equals change in v over change in t. Okay, so a average equals 10 meters per second minus 0 meters per second over 3 seconds. And with that, I get a